Welcome back to this Lernard.com Ansible section on roles. Roles are a method of combining tasks and other settings into reusable packets of functionality, usually with a fairly similar purpose. In the last section, we looked at using the playbook to run a list of tasks, defined directly in the playbook itself. This is already a powerful way to combine lots of changes into a version-controlled repository that can be used over and over again, but that list of tasks is likely to be very specific to the type of server required. For example, in the last section, our task list installed Apache and configured the web firewall, so that combination of tasks is very much web-oriented. With that in mind, the concept of roles can be introduced, which are collections of tasks that can be grouped together to perform changes specific to a scenario or to a server type, and then called all together from the playbook using a single role name. So, rather than calling a task directly, a playbook might now call a list of roles, each of which would then themselves contain the list of tasks. It's a further level of nesting for our functionality. To help illustrate this concept, let's expand out this general diagram and give some specific use cases of how this might work. Here you can see three roles, that of web, database, and a general purpose role called common. Each role contains a list of tasks specific to its name. So the web role contains our Apache install and web firewall changes we covered in the last chapter. The DB role contains the install of MySQL and database firewall changes, and the common role contains a few general tasks that could be applied to all servers. It would be possible to just have three separate playbooks, of course, but organising tasks into reusable units of discrete functionality like this can make playbooks much easier to read and understand, and allows for sharing of roles between multiple playbooks, so it can be a real time saver. In this simple scenario, for example, a web server might want the web and common role applied to it, and the DB server might want the DB and common role applied to it. We've been able to reuse the common role in two separate playbooks. Those of you that have just done the Terraform chapter may recognise this pattern as being quite similar to Terraform modules, and you'd be bang on. There's a huge community around creating these roles, and you can find literally thousands of them pre-made for you at a place called Ansible Galaxy. These roles can even be downloaded using a special Ansible Galaxy client that's run from the command line, and it's well worth a play with. It's a fantastic time saver for getting hold of roles, and is actually used genuinely in industry as well, but I'm not going to go into it in this section, and possibly not in the entire chapter, as I think we're going to build up more understanding when actually learning Ansible by doing everything from scratch. But once we start to feel more comfortable, perhaps I'll cover it right at the end. In any case, that covers the core concept of why we want to use roles. So let's hop on over to our Ubuntu VirtualBox machine and make some for ourselves. You'll be used to this drill by now, but first we want to make a copy of our work from the last section to build on. If you haven't been following along, don't worry, as all this can be downloaded from the Lernard.com GitHub repository, the link to which can be found at the bottom of this player. So, let's cd into our Ansible repo here, and so far we've created up to section 3. So now let's copy that folder and call it section 4. Okay, there we go. Let's open this up in Visual Studio Code, and the first thing we're going to do here is create some structure for our files to live in. Roles live in a folder called roles, which shouldn't be too hard to remember. Inside roles, I'm going to make a role called common, which, as I mentioned, I've chosen to give that name because I'm going to put tasks in there that could feasibly be applied to any and all servers. Inside common, I'll then make a folder called tasks. And once again, this folder must be named tasks. It can't be named anything you want. And finally, inside the tasks folder, I'll create a file called main.yml. Now I'm going to repeat that whole process for a role called web that will also live in the roles folder. Again, a folder called tasks, and then a file called main.yml. That structure has gone quite a few levels deep already, so let's just have a quick look at the diagram here to get some insight into what we're doing. For those of you that did the last chapter, you'll probably remember Terraform was pretty relaxed on its naming and file structure. I strongly recommended a layout, as Terraform themselves recommend it, and it's commonly used in industry, but it wasn't compulsory, and wouldn't affect how Terraform worked if you did decide to just cram everything into a single file or folder. Ansible, in comparison, is a bit more tightly controlled in terms of what you can do. Some things need to be named a certain way for it to work out of the box, and if they're not named that way, Ansible won't go and pick them up. This diagram will hopefully make that a bit clearer, along with giving you a window into what we're going to be developing in later sections. Thankfully, Ansible structure is very clear and simple to understand once you get used to it. So to start with, here's what we've got so far. A playbook and hosts file in the root, plus a directory called roles. The roles directory can store roles of any name. We're going to write a couple ourselves from scratch, but as I mentioned before, there's an enormous library of roles and other stuff available at Ansible Galaxy for once we get going. Roles can be named whatever we want, which we'd normally base on what the role does. So for example, in this section I'm going to make 3 roles. A common role, a role for web server related changes, and a role for database server related changes, as we mentioned before. If we expand a single role here, the folders we find inside are again fixed in name and shouldn't be changed. We don't have to have all these folders by any means. Each of them serves a specific purpose, and I'm going to go through them all during this chapter. For the section that we're in now, I'm only going to bother with tasks to keep the example nice and simple initially. But we wouldn't also want to go and put in here a folder of a random name, such as Wibble. We should only stick to the names in this convention. These folders can each contain different things depending on which folder it is, but the tasks folder we'll be looking at now contains main.yml. Most of the other folders apart from tasks are things that support and enhance the things in the tasks folder, such as variables and templates that can be copied over and put into the tasks. As we discussed earlier, roles are discrete collections of functionality, bundled together for convenience, so I think it makes sense to think of them in terms of tasks rather than any of the other things in the other folders. Okay, I'm rambling a bit now, so let's get back to it. Let's switch to the playbook_web file we created from the previous section, which contains a list of actual tasks. We're going to move these into the role now rather than running them directly from the playbook. So we'll cut them out of here, then paste them into the main.yml in the web role. Let's also highlight this install block and copy that into the common main.yml file. And then I'll just change this here from install Apache to install Vim. You probably all know this already, but Vim is a very common text editor for Linux. I'm just choosing Vim as a random example of the sort of general purpose change you might want to apply to every single server in an enterprise, regardless of its function. I should say that in very secure scenarios such as a bank or similar, people very frequently don't include any editors on their servers, but just for now it's a good example of something nice and general that we can apply everywhere. Right, let's open the web playbook again, and now all those tasks gone, we don't need this task header anymore. Let's change this to say role, and now we can just call the roles that contain the tasks that we want. I'm also going to change the hosts to web instead of all, and I'll show you why in a minute. You can see already that this looks a lot clearer than it did before in terms of functionality. All of the complexity of the tasks have been abstracted out into the role, so now when we look in the playbook, we can see straight away what the web server is getting. It's getting our web role, plus whatever tasks are in the common role. This concept of applying more than one role is a key benefit to the playbook role structure. Obviously, at the moment, our common role is really only installing Vim, but imagine a scenario where there might be 20 or 30 complex security and update requirements you wanted to add, plus maybe changing the login message on all the servers to your company legal warning, or creating some default users perhaps. All we'd have to do now is add all of that complexity to the tasks in the common role, and we can have all kinds of separate playbooks for different types of server and different types of context. As long as they all have the common role, they'll all get those changes. Sure, we could put them into each playbook manually if we had a list of tasks there like in the last section, but imagine if one of the requirements changed. We'd have to go and update the task in each and every playbook, whereas by abstracting the details out to roles, we have a single place to update any common changes. Let's go and spin ourselves up a server again to test this on. Again, if you're using a second VirtualBox server and don't want to use Terraform for this, that's no problem, just keep doing that. For the rest of us, let's run a quick Terraform apply here and we'll get our server IP to add to hosts. There we go. So let's copy that here and head to our hosts file. Now, a quick difference to previously, let's open up a pair of square brackets and write the word web inside them. I've alluded previously a couple of times in this chapter to the fact that multiple hosts can be organised to groups in our inventory file, and this is how it works. I'm going to create a group here called web. And if you remember, I scoped hosts in the playbook to only hit hosts under the web group, so that when I run that playbook, it's going to apply to this host because this host is under the web heading. Of course, there's only one host here, so I could have left it on all, but in a moment we're going to make some more headings and more hosts. Okay, so we've created our roles. We've got the playbook calling those roles, and the hosts file has our list of web servers in it. Let's run this and see what happens. So, cd back into the section 4 directory, and the command pretty much won't change from now on. It's going to be ansible-playbook -i hosts, and then the playbook name. And there we have it. If we have a look at this in more detail, it's clearly applied both roles that we added, our common role, where it's installed Vim, and it's applied our web role, installing Apache and making all those firewall changes. It's also applied it to the correct server, which isn't really surprising seeing as we only have one server so far. Right, let's jump back into Visual Studio Code, and now we're going to create a third role by copying our web role and renaming it to DB. In the main.yml file, I'm going to make two simple changes. Firstly, I'm going to make it install MySQL rather than Apache. And secondly, I'm going to change the firewall port alterations to only allow 3306, which is the default MySQL database port. Now, as you've probably guessed, we're going to apply this to a separate DB server, so I'm going to need to spin one up to apply them to. All I'm going to do here is duplicate the Terraform to spin up a second server, and I'll dump it all in the same file again. Don't worry at all about doing this by hand. Feel free to just go straight over to Lernard GitHub page and steal all the code from there, unless you particularly want the Terraform practice, in which case great, dig right in. If you do choose to go and get this from the Lernard GitHub page, don't remember to update your public key as we did before so that the Terraform code will actually work rather than saying there's an access rights error. Remember, if you want to see that done step by step, that's all good. Just go back to section 2 in this chapter for a reminder. Okay, back in the terminal now. Let's run up our second server by reapplying the Terraform. I'm going to do a plan this time. Two to add looks good, so now I'll quickly apply it. And there we go. It's now outputting 2 IP addresses. Notice that the IP address of the web server hasn't changed, and that's because I never spanned the server down. So Terraform is behaving idempotently as we would like, and it's just adding the DB server alongside it without molesting in any way the web server. I'll just get a copy of that here, and let's pop that into our hosts file. As before, I'm going to write a heading DB in square brackets to define the hosts under it as DB servers. These headings can be anything, by the way. I'm just choosing DB and web as arbitrary labels that best describe what I think these servers do. Before we run this, I want to just quickly hop over to the AWS console to check that Terraform has done exactly what I thought it would, as I did write that out by hand. Good. We can see there that there is one database server and one web server happily chugging along, so we're ready to go. At the moment, that database server is blank, so let's hop to Visual Studio Code and copy the web playbook here and rename it playbook_db. We'll change the name to install MySQL. We want to scope hosts so that it only hits hosts in our inventory that are under the DB group. And finally, I want to apply the DB role I created to those servers. But again, also the common role, which has stuff in that every server is going to want. So, back in our section 4 directory, and we once more run the same Ansible command. Done! Once again then, we can see that it's done the common task of installing Vim, but now it's hitting only the servers in the DB group rather than the web group previously. It's then applying the DB role, installing MySQL, and making the firewall changes required to only allow MySQL traffic. With this moment of success, we're done with this section on roles. We're only 4 sections into this chapter, and if you've already fully absorbed all the stuff we've been talking about, I'd be confident you could walk into any Ansible heavy role and be up to speed within a couple of weeks of late nights before anyone was the wiser that you weren't already a red-hot Ansible expert. When I stay up late in the evening swirling a brandy writing sonnets about my love of Ansible, a recurring theme in my verse is how easy it is to learn. We've got a few more things to cover in this chapter, around handlers, variables and templates, but honestly, from a conceptual standpoint, we're pretty much done. Remember this structure of playbooks calling roles, of combining roles to create complete server functionality, using grouped host files to group servers of particular types, and everything else you're going to learn is just icing on this already most excellent of cakes. Right, finally, let's behave like the formidable DevOps engineers we're now actually becoming by committing all our code back to GitHub. So, cd back to the root, git status to see our changes, and if we're happy with them, git add -a, git commit with a sensible message, and then finally, git push origin master. Okay, I'm aware of the fact that in this chapter I've been talking even more rubbish than I normally talk in terms of enthusiasm, because I love Ansible and I love the roles playbook combination for applying configuration. But I think rather than embarrass myself any further, let's jump straight into the next section where we start taking a look at variables. Hopefully see you there.